This video goes with Kuta handout number 14, and I'm going to break this up into 3 videos so I can get them on YouTube. So if you're a student checking this out, Kuta Video A is going to basically cover the first part of the handout. Kuta Video B will cover the middle part, and Kuta Video C is going to cover the end of the handout. So we're trying to use our exponent rules again, and so I'm just going to do a couple examples here. I'm going to start with problem number 1, and if I want to write this in expanded form so that you see how the rules apply, I would take 6b and I would say in expanded form it just means 6 times b. And then times, and then I have 2b to the 4th, which would be 2 times b times b times b times b. That's expanded form. So if I wanted to simplify that, it should be obvious that I'm going to multiply the coefficients. So a positive 6 times a positive 2 is a positive 12. And then I have 4 or 5b, so it would be b to the 5th power. So that's expanded form. And students, if you're having trouble doing any of these problems, try to do expanded form. But here would be the shortcut by applying the rules. You're going to multiply the coefficient. So positive 6 times a positive 2 is a positive 12. And then b to the 1st power times b to the 4th power. The rule is keep the base. The base is the same, keep the base. And then add the exponents. So let's apply that rule to a couple more problems here. So problem number 4, I'm not going to write this in expanded form. I'm just going to go ahead and use the rule. We're going to multiply the coefficients. 5 times 2 is 10. 10 times 3 is 30. And then, of course, my base is x. It's the same base throughout each term, so I'm going to keep the base. I'm going to add the exponents. 2 plus 2 plus 3 would be x to the 7th power. I think I'll do one more. Let's see, problem number 8. Let's see, positive 2 times a positive 3 is a positive 6. Keep my base x. X to the 1st power times x to the 4th power. Add the exponents, becomes x to the 5th power. We go on to the next thing. Let's see, now we're going to try to simplify ratios that have exponents. And once again, I'll give a couple examples. And I'm going to write these in expanded form, and oftentimes this is the easiest way to solve these. So 5r to the 4th is just 5 times r times r times r times r. All of this is divided by 2r cubed, which is 2 times r times r times r. When we simplify fractions, anything we see on the top or the bottom we can cancel out. The 5 over 2 can't be reduced. We'll leave it as an improper fraction. But r goes into r once, r goes into r once, r goes into r once, r goes into r once. I'm going to keep canceling here. Finally, the only thing I have left on the top is just 5r. And then, of course, the only thing left on the bottom is 2. So 5r over 2. I think I'll do problem number 12. Problem number 12 in expanded form is 2 times n times n times n times n. All of this divided by 3 times n squared, which is n times n. And if I want to cross cancel here, 2/3 can't be reduced, but n goes into n once, n goes into n once. I can cancel top and bottom. The only thing I have left now is 2n squared on the top. And of course on the bottom, the only thing left is 3. Apply that for all of the problems reducing ratios. This concludes Kuta Video A. If you need help with the middle or the end of the handout, refer to the other videos.